All right, I'm going to ask that question again, and Juliet's going to look really good because she has her original right answer, and we've agreed on the acronym, or the initialism rather. So, what is an API?
Um, an API is an application programming interface that could work with an I missed it again. That could work with an operating system, right? To try to talk to one another. I already forgot what I said. Something like that.
It's yeah, pretty much it's a go-between, and APIs can go between all kinds of things. Um, they can go and fetch information from a database. They can work with your operating system to help gather information from your computer's inner workings and then bring it to you to display. Um, Without giving too much away, for real life examples, um, let's talk about some metaphors for them. Lord Commander Mormont is in here, not because he's cool and he's the commander of the Night's Watch, but because of his raven. So the raven is actually a metaphor for an API because he carries messages back and forth between two endpoints. I've also seen a pretty cool video which described APIs as waiters. They take your order to the kitchen. They ask the kitchen nicely to fulfill the order. The kitchen fulfills it, hands it to the waiter, and the waiter brings it back to you. So what are some other metaphors for APIs? I can hear you guys across the room, by the way. Still listening.
Would a mailman be an API?
That's a great example of an API. He doesn't even look inside of the letters, or at least he shouldn't. So it almost doesn't matter what he's handling. He knows the destination. Back in the old days, you used to be able to put a little bit of change in the mailbox to pay for a stamp if you didn't have a stamp on there. Yeah, mailman's a great example. What else do we have? I've got another one. In a drug dealing organization, there will frequently be a lookout, and the lookout will let you know when the popo's coming. But they don't actually say the popo's coming. You know, you don't just announce that into the darkness. They have symbols. They may drop a text. They may pop around the corner and tell this guy who tells the other guy. And in fact, all the way going up a criminal organization that's well organized, no one talks directly to the boss. The boss gathers data from the next man down. So in a sense, every chain in that criminal organization is an API. Snitches are an API. Cops aren't getting information from going directly to the source. All right, one more student-provided example of an API. Well, a metaphor for an API.
Well, I guess it's along the same lines as a mailman, but like a messenger, like I'm just thinking along as a go-between. So like somebody that could give like a message to somebody else or something like that.
Yeah, like those old school singing messengers. All right, that's a good metaphor. I can dig it. But what about real life APIs? Something a lot of people use who aren't old, boring married people, Tinder is an API. Everybody has their own little collection of data, and you use the Tinder API to figure out whether they're a match for you. You're using an API to see the picture of them to decide if they're hot. And then when you swipe, they know whether or not via API you're interested in them. Okay. So what parts exist in an API? Juliet, the first thing you said before we started recording was about permissions. So APIs control whether you're logged in, whether you have access. They can also do like the waiter or like the messenger, and they can carry a request, get it fulfilled, and come back. They also control what you can request. I can't go into Tinder as one user and figure out how many people this potential person has swiped on, because that's judgmental and it's also creepy. So the API is there to control you knowing what's going on. Back at NSA, we had APIs embedded to keep people from accessing stuff that they were not cleared to see. So secret clearance only looked at secret clearance stuff. And if you tried to look at top secret reports, you got locked out. If you kept trying to look at top secret reports, it took down your information and it reported you. So yeah, and then the response, of course, has to happen. It's not going to deliver it to you and then not tell you that it's delivered you the information. So APIs are everywhere. They're online. They're embedded in HTML. They work between you and your operating system. If you want to imagine what life is like without APIs running everything, go to a really basic Linux machine and try to do everything yourself. Yeah, client-server model is probably the most frequent and the most visibly available. So I think of banking as this kind of a situation. Banking is a very popular thing. You log into your online banking and you can see just the stuff that applies to you, but underneath the hood, your API is almost running a query, fetching your information, bringing it back to you.
So I have a question. How the data being shared among APIs? So for example, like Chase, they use your, you can buy like air tickets or rent a car from chase.com. And so let's say if Chase is connected to one of the traveling sites, does it mean that they share the transaction information between the traveling site and Chase?
Sort of. So kind of like in SQL, there are keys that connect different data tables that come from different sources. In APIs, Chase has its API that it's sending out to interact with this third-party company, sends its API to meet it, and then they trade information in between. So that way, only the information that needs to be shared in order to make that transaction happens.
So like a joint table, they both have access to.
And the joint table is going to be a lot more limited than both of the individual tables.
Okay.
Yeah. So there with server, we just defined what client and server kind of looks like. That Chase example was very good and timely because it talks about actually a point I was hoping to make, that you can have an entire chain of APIs working together. You can have a network of APIs that communicate with one another. It can be super complicated or it can be super simple. So aside from Chase, do we have any other questions about APIs we may have interacted with?
So like the Facebook Cambridge Analytica scandal thing, essentially I guess like Facebook needs to do a better job controlling the access of their APIs, right?
Accesses of the APIs and also some InfoSec as well. That's not just related to the APIs. A lot of money was lost. But yeah, better encryption systems always help.
Okay.
All right. Yeah. Cool. Well, with that, I'm going to hand it to Matt.
All right. So for my part, we're going to actually jump into a notebook. In the folder, it's the APIs notebook. So if you all want to just open that now. And you should see this. Everyone got it open? Thumbs up if yes. You too, Marissa.
Ooh.
Sorry, I thought I was unmuted. I clicked on the API and you said it was called API Notebook.
Yeah, it's just APIs.ipynb.
Gotcha.
Good. Okay. So usually I do a code along. This is going to be more of a run along. The code's already here. We're just going to kind of hit enter, and I'll kind of talk through what happens, why we're doing this, and how it all works. So from the top here, it's just kind of some more information. It's a lot of the stuff that Aubrey went over, so we're going to kind of skip down through that. It just gives you another overview of client, server, and database. So if you go down here to the code example, so there are a couple different libraries in Python to interface with APIs. There's URLlib and URLlib2, but they're kind of complicated. So we're going to use an easier one called request, and it's really easy to import. You just run import request, and then to get send a request to a website, you do request.get, and then you pass in the URL. So in this cell, we're making a request to just google.com. So if you run that, that will send the request and save the response as this response variable. And now we can check the type of that response variable. You can see it is a response. And now from that response object, we can get the status code to see if our request was successful and print that out. So we see we got a response code of 200. That's a good sign. If you get like 200, 201, that's always good. If you get in the 400s, that's bad. You can read a little bit more on response codes, and usually each website or API will have kind of different meanings for each one. So now if we go into the text of the response and run that, this will actually print out the HTML for google.com. And kind of scroll down through.
So what does it mean? It just means that you get information from google.com, or you can actually search using this API?
You probably could modify the URL to like submit to a search page. But this is kind of just showing how you can basically like ping a website and get its HTML back as a response. And that's what you can
HTML means like how it was written?
Yeah, it's like the website code basically. So like if I copied all this into just a text document and saved it as an HTML and then opened it in a browser, it would pull up like a Google website page. And then from the response object, we can also get headers. These are different pieces of data that gets passed back down to us. So for example, we can print out the date and the server headers here. So we can see the time and date when we made our call. And then the server, GWS, stands for Google Web Service. So that's kind of how we can get some parameters back down to us, but we can also send parameters through our request. So this is using a website called HTTBin. It kind of just lets you test out a bunch of API calls. It doesn't really do anything. You can basically pass it anything you want. So here we're sending some mock credentials, username Luigi, password I love Peach. Doesn't really mean anything, but this would be like if you were logging into a website. So you kind of set it up as a dictionary or a JSON object, and then you set parameters in the get command as that dictionary. And so we get our response as R, and we can get the JSON of the response here, setting it equal to results, and then we can display that. So in this, we can see what we passed in, the password, the username, and then we can see, let's see, we can see the URL that we ended up submitting. So by doing this request to this website here, httbin.org/get, it actually is the same as sending a request to this full URL here with the username and password passed in. So we can also send up files, and we can send up multiple files. So again, using the HTTP bin, we can actually send up 2 random pictures. You can take a look at these. They're in the folder for the lesson, but it's just a random picture of a cat and a dog. So if we send those up and get the response, what this does is actually send the pictures back down to us, but it sends it as this really long string, which doesn't make a lot of sense to us, but it just kind of confirms that it worked. And if you notice how it was sent up here, we actually used, instead of params, we used the files attribute and passed in a list of files. And you can kind of see the structure of passing it in. We have to tell what type of file it is. We have to give it the file name. We have to open the file and pass it in. And then we also have to have the specific type. So like the first one's a PNG, but the second's a JPEG.
Question. So I opened this website and it looks like a fake website. What does it mean to send images to it?
It doesn't really do anything. I think it just says it submits it back to you, whatever you send up. It's just kind of to show what's possible.
Okay.
If that makes sense.
But if you were to log into a different site that wasn't a fake website, you could log in and then you could send images up, and maybe it would be in your stored media on that website to later use.
Like user-generated content.
Yeah.
Yeah, or like on Slack, if you like upload a profile picture, like it would be like that.
Okay.
So in terms of authorization, a lot of the time you have just like a token that you need to pass in, but it's not the most secure thing. So there's something called OAuth, which is kind of more widely used now. It's basically like having a username and a password, except it's called an API key and a secret. And without those, you won't have access to the API, and it basically won't permit you from interacting with it. So here we're going to try out an API. This is for the LifeX API. If you open the link here, it opens up the documentation page. What LifeX is basically smart light bulbs. They connect to your Wi-Fi. You can control them with your phone, do lots of cool things with them. They also have an API. So you can make API calls to your light specifically and make changes to it. I actually have 2 of these lights. They unfortunately burnt out, so you won't be able to see a live demo, but we can still actually make calls to them. So here we just import the libraries we're going to need. So for this API in particular, we just have to pass in a token to gain access to it. And this is my personal token, so I'm probably going to have to change it after this because you all know it. And if my lights were on, you could probably do a lot of crazy things with my lights. And usually when you have a token like this, you don't want to just have it pasted there. You kind of want it in a more secure place so that people can't get their hands on it. But if you run that, it'll just create our tokens object dictionary here. And then from that, we want to grab the token itself and pass that in as a header. And this is just kind of the format it has to be. You have to have the key be authorization. And then for the value, it has to be bearer and then a space and then the token. When you go through the documentation, it will tell you that here in the authentication. It'll kind of tell you how to pass up the token and do all that. When it comes to APIs, documentation is your best friend. Almost every API will have a pretty thorough documentation. It tells you all the different endpoints. You can see here, like this one will list the lights. It tells you the parameters you need, the result that you get back, and you can kind of go through all the different options. So let's see. So here we're going to send a request to the lights/all. So I think that just gets all the lights that I have. So if we run that and then run this next one to get the response, we can see this pass down some JSON of both of the lights I have. And then we can actually just create a data frame of those lights to view it more easily. This puts it all into a nice table. You can see what we get down. We can get the brightness, the color, whether it's connected. And then for each one, we can just print out the name of it. So like I have one, my mom has one, and that just tells you the names there. And so for these last 3 cells, this is kind of just doing different calls. This first one would power the lights on. So for here, our payload that we have to pass up is this whole dictionary. If you go into the documentation, again, it would outline this, what the keys have to be, what you have to pass in for each one. And then you just make your request. You set the data equal to a JSON version of the payload here. And you pass in the same headers, which the headers, if you remember up above, was just the authorization and the token. So if we run that, we should get a good response back. Yep, it just says they're offline because they're not connected to the internet, but it did try to successfully make the call. And then this next one is just to power on with color. So a cool thing about the lights is they can be any color, and you can just change it however you want. So here, this would make it blue, set the brightness to 0.5, and modify some of the other parameters. And go ahead and run that. And then this last one just would turn off. And you can note the endpoints for these last 2 is lights/states, because you're kind of modifying the state of the light, whether it's on or off. And yeah, that's kind of the basics of how it would work. It gets a little bit more complicated than that once you have really specific things you're trying to do. But like I said, the documentation's your best friend. You always want to, really go through it thoroughly. And it should be able to tell you all you need to know to make the calls you want.
Can you give us an example? Like you turn on with color, what documentation you look through to create this code?
So if you look on here on the bottom left, the endpoints, I see set state. So I'm going to click on that. So here, this tells me what parameters I have to pass up. So the selector is which lights I want to modify or turn on or off. And if you go back to the code here, I think we got that from our initial call that brought down both of the light objects, and then we just got the IDs from it. And then for the body of it, you want the power on and off, color, brightness, duration, all those other variables. And then if you go down here, there's even a Python option. It shows you exactly how to do it. You could basically copy and paste this.
Okay.
And you could modify the payload however you want. That's the other thing about API documentation. Sometimes they even have it so you can try out the code in the browser. You can put in your parameters and it will do the call right there so that you can test it before you do it in your code. And then this shows you the format of the results. So you don't have to, check the type of it, go through all the keys. You kind of know what you're going to get back and what you can grab from it.
And you just mimic the data structure in the original data, right? All the dictionary nested.
Yep, it's basically always going to be like nested dictionaries.
Nested dictionary sounds a whole lot like what?
Yeah, I feel like the hard part is to understand the data structure, and because we work in a pandas environment basically, and it's easier.
But I mean, the good thing is that if you have JSON and you're having trouble like understanding it, you can always just convert it to pandas to make it easy to kind of understand the structure. That's kind of what I usually do. I go straight to pandas as quick as I can because it's just easier to look at.
Right.
And so with all that, how do you guys feel about trying out some of this with a different API? Think you're up to the task? Thumbs up, thumbs down, thumbs sideways?
Up to the task if you have a partner.
Does that change anything? Still sideways? What do you think, Aubrey?
I think it's going to be easier than y'all think it is.
Honestly, like I know it's me and I've made some tough problems in the past. This one is not so bad. I basically outline it step by step. The only challenging part is the last question, but that's a given. And if we do break into pairs, Aubrey and I can kind of bounce around and be there to answer questions and help you out.
Or if you would like, we can keep it in homeroom and y'all can try to solve it as a blob. And just alternate who is the keyboard manipulator. Y'all got to vote.
Thumbs up to what?
I'm happy to just watch.
I'm good either way, I guess. I'm looking at it now, and you did outline it pretty easily, I guess.
Okay, so I
Do
think
we want to start off in pairs, and if we come to the conclusion it's better off in group, we can reconvene?
Yeah, we'll put Jacob with Marissa and Juliet and Bonnie together.
Okay, and so the file is just the API's activity students. You're going to be working with the Genius API. It's basically a collection of song lyrics, musical data, something fun, lighthearted to work with. You will have to sign up for an account real quick just to get an API key. It's really fast and easy though. You'll have to fill in like an app name and a URL. You can put anything for the app name, and for the URL, you can just put your GitHub URL and that would be fine. And once you have that, you'll kind of get a screen here that gives you the client ID, the secret, and then all you need is the access token. So you'll just click generate access token, copy that, and you can paste it in your notebook. And from there, you should be good to go. And then there's just a few different questions. It's all pretty guided. You search for a song, you look up a song, and then you have a little challenge at the end. I give you the song ID, and you have to tell me what song it is and a little bit of info about it.
Compared to the doozy from Monday, I think this one is pretty all right. Okay, yeah, we'll give you all like 5 to 7 minutes to get your sea legs under you, and then we will stop in and see how you're doing.
All right, so I'll go ahead and pause the recording here.